Hello! So here we have a challenge for us from the Book of Integrals by Math Scribbles. We have the integral of 3x to the fifth minus x cubed plus 4x squared minus 12x minus 8 all divided by x squared minus 2 dx. I'm going to do this via exploding dots. So going ahead and doing the division here is a picture of our numerator. We have 3x to the fifth. So we have 3 dots in our x to the fifth box. Now we have minus x cubed, so we have an anti-dot or a tod in our x cubed box, 4 dots in our x box, 12 anti-dots or 12 tods in our x box, and then 8 tods in our ones box. And we're dividing by x squared minus 2. So looking at this picture, how many groups of x squared minus 2 do we see? Well, what does x squared minus 2 look like? I mean, x squared minus 2 is going to be 1 dot in our x squared box, but it's going to be 2 tods in our ones box. It's going to look like 1 blank 2 tods. So looking at this picture, do we see any 1 dot and then a blank and then 2 tods? Well, I see some right away. Here I see 4, so I could see 1 blank 2 tods. But then looking all the way down in the x to the fifth box, well, we have 3 dots, and then we have a blank, and then we have 1 tod. So wouldn't it be nice to have 2 tods to go along with this 1 tod, right? So we go ahead and just put in another tod. Well, now look, now we have that 1 blank 2 tods. But if I put in a tod, I'm going to have to put in a dot to go with it. Because then a dot and a tod together in a box, they're going to annihilate and just go poof. So there's still only 1 tod right now in the x cubed box. But now right away I see right here, I have 1 dot blank 2 tods. And that's going to be 1 group at the x cubed level. But then, the same thing, we have these 2 more dots. It would be nice to have 2 tods to go along with each of these 2 dots. So, if I put in 2 tods here, now I have 1 blank, 2 tods, but I better put in 2 dots to go with it. And then for this dot, I can put in 2 tods as well, but I better put in 2 dots to go with it. And then right here, I see a dot, blank, 2 tods, dot, blank, 2 tods. That's going to be 2 more groups. Now I see 3 groups at the x cubed level. Okay, but now looking at this, well, now look, I have a 1 blank 2 tods right there. That's going to be now at the x level. Do we have any more? Well, sure, right? For each one of these dots, I see dot blank 2 tods, dot blank 2 tods, dot blank 2 tods. So I have 4 dots here. And for each one of those dots, do I have 2 tods? Well, sure, I have 2, 3, 4, 5, 6, 7, 8. So basically 8 of these would account for all of these dots. So those 4 dots, each one of those dots is going to pair up with 2 tods, and that's going to be 8 of these. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 of these. So 8 of these. And that's going to be 4 groups plus the 1 group. That's going to give me 5 groups. 5 groups at the x level. Do we see anything else? Well, sure. We have these 4 dots, and each one of those is going to, again, pair with 2 tods. And we have exact matches, right? Because we have 2, 3, 4, 5, 6, 7, 8. Each one of those 2 is going to pair with one of these. So that's going to give us 4 groups. 4 groups at the ones level. But we still have these 2 anti-dots, these 2 tods, in a sense, left over at the x level. What else can I do? I don't know. So that's going to be our remainder. We have a remainder of, 2 anti-dots, so a remainder of negative 2x. So what is the answer here? Well, the answer for the division is going to be, we have 3 groups at the x cubed level. So we have 3x cubed. And then we have 5 groups at the x level, so plus 5x. And then we have 4 at the ones level, so plus 4. But then we have 2 anti-dots, in a sense, still waiting to be divided by x squared minus 2. So that's going to be minus 2, since they're anti-dots, still waiting to be divided by x squared minus 2. So therefore, this integral is equivalent to now this integral. And now this becomes pretty simple. Integrating here term by term, the integral of 3x cubed, we add 1 to the exponent, divide by that. So we're going to have x to the 4th over 4, and then we get plus, well, the integral of 5x is 5x to the 2 over 2, so we get plus 5x squared over 2. Integral of 4 is going to be plus 4x, and then we're going to have, well, we're going to have minus 2, and then times the integral of this is not just 2, it's minus 2x. It's minus 2x because we had, it's not just 2, it's 2 at the x level. So we have minus 2 times the integral of x over x squared minus 2 dx. But it's a simple u substitution, letting u be equal to x squared minus 2. Then du is going to be 2x dx. So 1/2 du is going to be the x dx. So the 1/2 du is the 1/2 times the 2 is going to give us just 1. This just becomes minus 1 over u, which is the natural log of the absolute value of u. So therefore, in the end, what is the answer? Yep, it's just going to be 3x to the 4th over 4 plus 5x squared over 2 plus 4x, and then minus the natural log of the absolute value of x squared minus 2 plus a constant. Calculator, take care.